So add and subtract unlike fractions. It's time. We have to do it whether we want to or not. Unlike fractions, unlike means that the denominators are different. So if you have a fraction 1/2 plus 2/3, the denominators are different. We can no longer just add across the numerator and get 3 over. Well, what would you do with this? Would you choose the 3 or the 2 to write over here? This is a big mess. There's nothing you can do with this unless you find a common denominator. So 1/2 plus 2/3. You want the least common multiple. What is the smallest number that you can multiply something by 2 to get and multiply something by 3 to get? I'm going to tell you the least common multiple is 6, or the least common denominator is 6. So I can write that over here because I know I'm going to end up with a denominator of 6. But how am I going to do that? Well, 2 times 3 equals 6, so I can certainly make this denominator equal 6. That's not a problem. As long as if I do it to the denominator, I have to also do it to the numerator. Same thing here. 2 times 3 is 6, so 3 times 2 in this denominator. Now 3 times 2 is 6. 2 times 3 is 6. Totally allowed to multiply this denominator by 2 as long as I also multiply the numerator by 2. So now I have 3 times 1 plus 2 times 2, and this is 7/6. So let's do a bunch of examples because nothing makes perfect like practice. Let's find the sum or difference, right? So we're going to add -3/8 to 1/2. Again, denominators are not alike, so we want to find the least common multiple. We're looking for the lowest common denominator, which is the same thing as, remember, the least common multiple. Remember the algorithm for the least common. We're not going to be thrown by the least common. We want to remember multiple. So multiples are bigger than numbers, and so we want to use the algorithm for bigger numbers. So let's start with our 8, which is one denominator, and write it as a product of primes. And our 2 is another denominator. Write that as a product of primes. And now we want to reduce the duplicates. And then because a multiple is bigger than a number, some number, the multiple of a number is bigger than the actual number, we want to add our extra parts in. 2 times 2. So our least common multiple is 8. That means our least common denominator is 8. Easy enough. Now let's go back to the problem. -3/8 plus 1/8. Oh, that's not what I meant to do, sorry. 1/2. Well, my first fraction is fine, even though I left room to multiply something in here. 8 is the denominator already. 8 is the denominator already. Good to go. Second one, 2. 2 is not the same as 8, but I could multiply 2 by 4 to get 8. Always allowed as long as I do the same thing in the numerator. And now I have -3/8 plus 4 times 1 is 4/8. Now I have like fractions, and so I can just take my fraction bar and put all of my operations above. -3 plus 4 is 1/8. Let's do another one. This time we have to deal with more negatives. So -1/4 minus, so we're looking for the difference, but I'm going to subtract a negative number. So the first thing I want to deal with is, let's just get rid of all these minuses and see what I can do to reduce that to something much more workable. So I have -1/4 minus minus right in a row like this means now it's a plus 2/3. Okay, I have unlike denominators. I don't like that, so I'm going to have to find the lowest common denominator. And to do that, I'm going to use my lowest common multiple algorithm right here as my lowest common denominator. So I have 4, which equals 2 times 2, and I have 3 that equals 3 times 1. We don't really care about the 1. And so my least common denominator, well, there are no duplicates, so I'm going to need all of my factors. 2 times 2 times 3. My LCD is 2 times 2 is 4 times 3 equals 12. So now I just have to set it up. I'm going to write the first fraction, but I'm going to stretch out the fraction bar, which gives me room to do these multiplications if I need to. If I don't, that's okay too. Plus the second fraction. I haven't changed anything yet. I've just stretched out the fraction bar, so I have a place to put my multiplications. What did I have to multiply? I decided that my lowest common denominator is 12. What do I have to multiply 4 by to get that 12? Well, 4 times 3 is 12, so I have to do the same thing to the top. What do I have to multiply 3 by to get 12? Well, that's 3 times 4, and so I have to do the same thing to the top. Now I can just do a little arithmetic. -1 times 3 is -3 over 12, plus 8, 2 times 4 over 12. And now I just have like denominators. -3 plus 8 is 5 over 12, and that does not reduce. So let's look at the same process involving monomials, because we've been dealing with monomials all year. So example, let's add m over 5, or let's subtract from m over 5 to m over 3. Okay, different denominators, so I have to create a lowest common denominator. 5 is prime, so I write 5. 3 is prime, so I write 3. There's nothing to reduce, right? Nothing to cancel out. So that means my lowest common denominator is 5 times 3, which equals 15. So set up m over 5 with an exaggerated fraction bar minus 2m over 3 with an exaggerated fraction bar. So what do I have to multiply 5 by to get my lowest common denominator 15? 3. Do the same thing to the numerator. What do I have to multiply 3 by to get my lowest common denominator 15? 2. Do the same thing to the numerator. Now I can multiply 3m in the numerator over 5 times 3 is 15 minus 4m. What did I do here? I did something wrong. Oh, I'm sure you caught it. I think I said 5 and wrote 2. If I said 2, it's just crazy town. 3 times 5 is 15. I know you were sitting there thinking, just when I thought I understood this, I don't get it at all. No, I just made a mistake. So m times 3 is 3m. 5 times 3 is 15. Good. 2 times m times 5 is 10m over 3 times 5 is 15. Now I just have like denominators. So I take my fraction bar and all my operations to the top. 3m minus 10m over 15. 3 take away 10 is negative 7m over 15. And we don't normally want to make our fractions with a little diagonal, but I just wanted to save room. Here at the very end, it's kind of okay. And so I did. All right, that's it.